In this video, we're going to talk about the sum and difference identities for sine and tangent. I want to take some time to derive a few of these for you, just so that you can see how they are building one upon the other. So we're going to start with the cofunction identities. The cofunction identities are a way to give a relationship between the cosine and the sine. And this is very much tied to the idea that the cosine and the sine are really the same shape as far as the graph goes, but they're shifted off by pi over 2 or 90 degrees. So this is another way of representing that. We're going to show that one of these is true. I want to prove the first one for you or derive it by using the identities that we looked at in the last chapter. So I'm going to bring those back up onto the screen. So in the last section, we looked at the cosine, the sum and different identities for cosine. So we can use the second one here, the difference identity, to help us kind of verify that these are true. Let's think of this 90 minus x. Let's think of the 90 as angle A and the x as angle B in the difference identity for cosine. If we do that, then this becomes, let's see, let's write this down one more time. So using the difference identity, this becomes the cosine of 90 degrees times the cosine of x plus the sine of 90 degrees times the sine of x. The cosine of 90 degrees is 0. So this is 0 times cosine of x plus the sine of 90 degrees is 1. I'm really picturing the unit circle in my head here. I hope you are too. Okay, 0, oops, I'm off the screen. 0 times anything is just 0. And 1 times the sine of x is just the sine of x. So we've verified, right, that the cofunction identity is true based on the difference identity for cosine. Okay, so these are called the cofunction identities. Now, in this chapter, we're going to take some time to talk about the sum and different identities for sine as well. And so they look very similar to those of the cosine, but this cosine and sine of each of these angles are kind of in a different order. So I also wanted to take a second to derive the first of these formulas for you, just so you could see kind of how we're really building up. We're using one identity to prove another, and we kind of used the sum and difference of cosine as our basis. Now we're going to use the two of these things together. All right, so we're going to start with the sine of A plus B. Using the cofunction identity that we just proved, the sine of an angle is equal to the cosine of 90 degrees minus that angle. That follows from the identity we just derived. Okay, and now we could kind of rearrange what we have inside the parentheses here. So this is the same thing as the cosine of 90 degrees. Let's distribute the negative. Minus A minus B. Now let's think of this a little bit differently. Let's think of this as the cosine of 90 degrees minus A minus B. So we're kind of thinking of this as one angle and B as the second angle. Okay, now we're going to incorporate the sum and difference identity for cosine. We had that on the top of the screen at the very beginning of the video, and we just finished a video dealing with this identity as well. Right, so this is equal to the cosine of 90 minus A times the cosine of B plus the sine of 90 minus A times the sine of B. All right, here's where all of the cofunction identities that we were just looking at come into play, right? The cosine of 90 minus A is the same as the sine of A times the cosine of B. And the sine of 90 minus A is the same as the cosine of A times the sine of B. So we have derived the sum formula for the sine. I won't derive the second one. I think the book kind of goes through that with you. It's not very difficult, but just know that these are kind of based on, we're building, right? We started with the cosine based on the distances. We added the cofunction. Those two together going to generate the formula for the sine. Now we're going to take the cosine and the sine and generate the formulas for the tangent. So let's do that next. All right, so we also have formulas for the sum and difference for the tangent. And just like we said for the others, right, it's not as simple as doing the tangent of A plus the tangent of B. It's more complicated than that. There's more to it than that. So we have two whole formulas here, right, for one for the sum and one for the difference. So let's take a second and derive the sum. As you can probably guess, we know that the tangent is the sine over the cosine. So we'd really like to use those two together. Let me see if I can get them both on the screen at the same time. Here's the cosine. I'm going to get this figured out. All right. Let's see here. Will this all fit? Almost. All right, let's say we have these two right here. Do this. Okay, and we're trying to derive the tangent of A plus B. I'm not going to be able to have these on the screen at the same time, but I'll scoot them in when we need them. All right. So we are going to start with the tangent of A plus B is equal to the sine of A plus B over the cosine. Okay, so now we'll pull these in one at a time. Now let's rewrite the sine of A plus B using our identity in the numerator. So the sine of A plus B is the sine of A times the cosine of B plus the cosine of A times the sine of B. All right. Oops. Now let's pull in our formulas for the cosine. For the denominator, cosine of A plus B is the cosine of A times the cosine of B minus the sine of A times the sine of B. Okay, and here's where I feel like we're, by deriving these, we're developing our verifying identity skills while adding formulas to our repertoire, right? So we're kind of killing two birds with one stone. This next part, to get from where we are now to where we would like to go, this I think takes some creativity, right? And it may not be really obvious right now how I'm going to turn this into this, or how I'm going to turn this denominator into this. So what we can do, we know that tangent is the sine over the cosine. And our goal is to try and get a 1 here, right? If we're going to verify this identity. Okay, so what we're going to do is divide everything by cosine of A times the cosine of B. Let me jot that off to the side. We're going to divide each by cosine of A times the cosine of B. Okay, and this, we've got kind of 4 parts here. We're going to do all of them. This is going to give us one of those fractions within a fraction. I know you love those. Okay, so we have sine of A, cosine of B, over, remember this is what we're dividing by, cosine of A, cosine of B. Same thing here. We have cosine of A, sine of B. We're going to divide it by this, cosine of A times cosine of B. You see where we're going with this? Okay, let's do the same thing for the denominator. And sine of A, sine of B, over cosine of A, cosine of B. Okay, some nice canceling is going to happen on the numerator. So the cosine of B for this first term is going to divide to be 1. And the sine over the cosine is the tangent. So this will be the tangent of A. For the second fraction in the numerator, the cosine of A will divide out, and we'll be left with sine of B over cosine of B, which is the tangent of B. Okay, for the bottom, these both cancel out. That's going to give us a 1 minus. And then we're going to have sine of A over cosine of A. That's the tangent of A. Sine of B over cosine of B. That's the tangent of B. So we have derived the sum formula for the tangent. All right. Well, it's really good practice for verifying identities. I chose just one more example to help you have a chance to use one of these identities to calculate. So let's do that next. This one comes from your book. So it's asking us to find the sine of 5 pi over 12. We did one of these in a previous video. I decided to do this one in radians just to give you an example of both. Okay, but we would like to break up 5 pi over 12 into 2 angles, maybe that we know a lot about, know the values for already. And we can do that, right? I think what's going to work best for us is 3 pi over 12 and 2 pi over 12. These add up to 5 pi over 12, so we're not changing anything. If I reduce them, divide both by 3 here, this makes pi over 4. I know a lot about pi over 4. And if I divide top and bottom by 2 here, this makes pi over 6. I know a lot about pi over 6 as well, right? Okay, so this is the sine of a sum. So I'm going to use the first formula here. So this is equal to the sine of pi over 4 times the cosine of pi over 6 plus the cosine of pi over 4 times the sine of pi over 6. I know the sine of pi over 4, that's 45 degrees, so that's the square root of 2 over 2. The cosine of pi over 6, that's 30 degrees, is the square root of 3 over 2. And then the cosine of pi over 4 is the square root of 2 over 2. And the sine of pi over 6 is 1/2. So if I multiply these, I'm going to have the square root of 6 over 4 plus the square root of 2 over 4. If I want to combine them into one fraction, it's going to look like the square root of 2, the square root of 6 plus the square root of 2 over 4. Again, this would be the exact answer, which is what we're going for right now. If we wanted to put it into our calculator and approximate it with a decimal, we could also do that. All right, I hope this gave you an idea of where these formulas are coming from. The sum and difference identities, I will have a formula sheet for those, so you don't have to memorize these, but you do need to be able to use them like we did in this example, and use them in verifying identities as well. So I hope that gave you a good idea about some of the strategies that are involved. So take some time and practice these, and we'll see you in the next video.